Today we're going to learn how to find the measure of interior and exterior angles of regular polygons. To help us with this concept, this is a chart we'll fill out together and we'll discuss how to find each box in the chart. Towards the beginning, the table will be really helpful and we'll use it frequently, but by the time of the test, you should be expected to find these measurements without using the table. Don't worry, it's not as intimidating as it sounds. Alright, so here's our chart. The top row lists regular polygons, and the row on the left lists the things we want to find. The number of sides in the polygon, the number of triangles after we triangulate it, the sum of interior angles, each interior angle as well as each exterior angle, and the sum of all exterior angles. So right off the bat, we know that the sum of exterior angles for every regular polygon will be 360 degrees. So you can go ahead and fill in that bottom row. By now, you should also know how many sides each polygon has, so we can fill in that row as well. In order to triangulate a polygon, we'll divide the shape into as many triangles as we can. So for a square, you know it has 4 sides, and we're going to divide it into 2 triangles. Another example is a pentagon. We know it has 5 sides, but we can only divide it into 3 triangles. A good rule of thumb is that the number of triangles after triangulating it will always be 2 less than the number of sides. So for our in column, we'll put in minus 2. And then we can go ahead and fill in the rest of this row as well. Building on that, in order to find the sum of interior angles, you'll find the number of triangles in minus 2, what we just did, and multiply that by 180 degrees. So for your in row, you'll have in minus 2 times 180. So for a triangle, it has 3 sides, minus 2 is 1 triangle, multiply it by 180, and you get 180. I'll go ahead and fill in the rest of this row for you, but when you're finding it yourself, you should be able to multiply it out. Next, you'll take your sum and divide it by the number of sides. So for in, that will end up being in minus 2 times 180, just like we had in the row above, but you divide all of that by in, or the number of sides. So again, I'll fill out the rest of this row for you guys, but using this formula, you should be able to find it on your own. Lastly, to find the measure of one exterior angle, you simply divide 360, the sum of all exterior angles, by n, the number of sides. So for n, we'll put 360 divided by n. So for a triangle, you would have 360 divided by 3, and you get 120 degrees, and so on. I'll fill in the rest for you. Let's do a couple practice problems. Here we have a hexagon. There are 6 sides, and when we triangulate it, we can either draw the triangles or do the formula in minus 2. We should get used to doing the formula because for some polygons you won't be able to draw the triangles in there. So you end up with 4 triangles. Next, we do 4 times 180, and we get 720 degrees for the sum of exterior angles. The next step is to divide this by 6, and we end up with 120 for each interior angle. Lastly, we divide 360 by 6 to find the exterior angle measure to be 60. Okay, one more problem. We have a decagon. If you remember, that means it has 10 sides. So n minus 2, or 10 minus 2, is 8. And that's how many triangles we would have if we triangulated this decagon. We do 8 times 180, and we end up with 1,440 degrees for the sum of interior angles. When we divide this by n, or 10, we end up with 144 degrees for each interior angle. Lastly, 360 divided by 10, we get 36 degrees for each exterior angle. Alright, so now we know how to find interior and exterior angles step by step. Thanks for watching.